Hi guys, so today we're going to take a look at simplifying radicals as we move forward in this next section of solving quadratics. It's going to be really important that we know how to reduce radical values. We're not going to just simply place it in a calculator and get a decimal answer. We want to know what the radical is in its simplest form. So on the very top of the screen, you're going to see the roots in the square table. Those are very common perfect squares that you want to be aware of. So from 1 to 12, even if you know, all the way out to 15 is great, but your most common ones are going to be 1, 4, 9, 16, 25, so forth and so on. Everything that you see on that table right there. So the easiest way to make sure that you are simplifying a radical completely is to see if you can divide out any of these perfect squares into the number that you're given. And you want to find the largest one, because if you can find the largest one, you're going to make less work on yourselves. There is also another way of doing it that involves factorization and literally taking the number and breaking it down to its primes, and then from there writing it in its simplest form. It's a little time consuming, and if you struggle with your prime factorization and you're factorizing numbers anyway, it is going to be a struggle. So I'm going to show you a little shortcut, easy way of doing that. So in this case, we have the square root of 72. So here's your shortcut. I take 72, I see where it would fall on this perfect squares table. So it would fall in between 64 and 81. And I'm going to start dividing. See if 72 can divide evenly by 64. It does not. You get a decimal. So then I move down. Can 72 be divided by 49? Nope, I get another decimal. Can 72 be divided by 36? It sure can. 72 divided by 36 leaves me with a 2. So that tells me 36 and 2 are factors of 72. They both get written in roots because I'm splitting that radical 72 into its two factors. And then I simply know the square root of 36 is a whole 6. So it becomes 6 radical 2. So I was able to do that in 2 little steps after I was able to do my division to find the whole numbers and the perfect factors of 72. Now, if you don't get the largest one on the first try, not a problem. You just keep going. So some people know factors and they know, well, 72 is made up of 9 and 8. Great, you are absolutely correct. Square root of 9 is 3, but the square root of 8 can go further. 8 can be broken down into 4 and 2, and the square root of 4 is 2, and the square root of 2, I don't know, it stays as is. So I would then multiply these two whole numbers that we got from the perfect squares. 3 times 2 gets me that 6, and again, I still have the square root of 6 in the back end. So that's how I'm going to be going through and simplifying these radicals. Now, if we want to do operations on radicals, adding and subtracting can only happen on like roots. They have to be identical. You're going to consider them like they're variables. So as long as they are identical, then I can add or subtract the coefficients in front. If they are not identical, like what you see in that bottom problem here, okay, this square root of 12 can be broken down into 4, square root of 4, and the square root of 3. This is then written as 2 radical 3. And then when I simply subtract them, 2 radical 3 minus 5 radical 3 gets me that negative 3 radical 3. And I know I have that toolbar on the bottom hiding it, but you can get the idea and you can look at it later. Multiplying and dividing, you can just do the operation on the radicals. They don't have to be identical. So the square root of 15 times the square root of 2 gets me the square root of 30, because 15 times 2 is 30. You would want to see if you could simplify it further if you can. So for instance, when we took a look at the 84 radical divided by radical 7, 84 divided by 7 is 12, and 12 can be reduced. Okay, just like we did before, it's the radical 4 times radical 3, which gets me to radical 3. So always make sure you write your answers in the simplest form. Okay, and the last thing we're going to take a look at is when you do division, you have the possibility of ending up with a radical in the denominator. You cannot leave a radical in the denominator. You have to simplify it by doing what is called rationalizing. So to rationalize the denominator, you will take whatever that denominator is, and you are going to multiply the top and the bottom, because this fraction technically reduces to a 1. So it's not really affecting the problem any. It's just giving us a new way to write it. When you multiply a radical times its identical self, you are simply left with what is inside, and then I can multiply the tops. So I have another example down here, 2 radical 6 over radical 15. I want to get rid of that radical 15. So I'm going to multiply, I'm going to rationalize top and bottom by that square root of 15. That is going to get me a whole 15 on the denominator because they are like terms. They multiply. I'm just left with the inside. And then on the numerator, the 2 stays whole. And then I multiply the 6 and the 15. I can only multiply things inside the radicals together. I'm left with radical 90, which again would then be left with simplifying. Radical 90 can be broken down into 9 and 10. Radical 9 is a 3. And then I'm left with 6 radical 10 over 15. And in fact, I can actually simplify that further because my whole numbers are divisible by 3. And that's where I get this 2 radical 10 over 5 from. Okay, so it's really important that you know how to rationalize your numbers. Okay, again, watch this video over and over if you need to. Do the practice problems that we did in class that we're leaving with you to continue to practice. And if you have any further questions, just be sure to ask.